And today my very important topic of quantum mechanics in the chapter of time dependent perturbation theory, adiabatic and sudden approximation. In the टाइम डिपेंडेंट perturbation theory जब मैंने पढ़ा है तो वी हैव डील्ड with the phenomena where the perturbation is small. मतलब we have assumed the perturbation is small. That means the perturbed Hamiltonian, very small part of the Hamiltonian that depends on the time is small. But we have paid no attention. बट मैंने ये कोई अटेंशन नहीं लिया है उसमें कि द रेट ऑफ चेंज ऑफ परटर्बेशन, दैट मीन्स जो हैमिल्टोनियन आपका परटर्ब्ड हैमिल्टोनियन है, अगर उसमें रेट ऑफ चेंज ऑफ होता है उस पर मैंने कोई भी अटेंशन नहीं लिया इन द थ्योरी ऑफ टाइम डिपेंडेंट परटर्बेशन. In this section, we take the attention on the rate of change of perturbation. There are two types of attention. The rate of change of is adiabatically, that means slowly, and other is suddenly. Rapidly means suddenly, and adiabatically means slowly. We assume H dash t, that means perturbed Hamiltonian, time dependent perturbed Hamiltonian, is switched on, मतलब it will start at t बराबर 0 and off after the time t. The turning on मतलब t बराबर 0 and turning off may be either smooth or abrupt, मतलब either adiabatically or the first order coefficients in time dependent perturbation theory is given by ak1t, मतलब particle in kth state at time t is equal to 1 upon I h cut h dash km. This on integrating, the first term is this and second term is this. If we assume perturbation is vanishes, perturbation ना लगे as t tends to 0, मतलब 0 पर start and t पर close, मतलब just close to the 0 time h dash km is equal to 0. So there is a no first term vanishes at lower limit. First term is vanishes at lower limit, मतलब t बराबर 0. So the equation becomes this. The first term in RHS represent constant term, but second term represent perturbation and produces transition. Now the perturbation divides in adiabatic and sudden. So in case of adiabatic approximation, we assume the rate of change of h dash km is very small, very slowly, so it will be taken outside of the integral. First term is vanishes, so this is a approximate equal to and dever h dash but a dever h dash km upon dever t does not equal to 0 in the interval t1 to t2. 0, so t is the time of application of the perturbation, but within this time t1 to t2, the term diver h dash upon km diver h dash km upon diver t is a constant, so taken will be outside of the integral. On solving you will get this term. In this case there is no transition in other state. Like, in this case transition to other state unlikely, मतलब transition नहीं होगा. Adiabatic approximation, adiabatic change of the h dash km, there is no produces of transition. That means adiabatic perturbation में transition की घटना नहीं होती है. वन स्टेट टू अदर स्टेट ट्रांजिशन पार्टिकल का नहीं होगा. Thus, the required condition of the following the adiabatic perturbation a k mod t मतलब probability is very less than 1. The probability of finding the particle in kth state is very less than 1. So from equation first, this term is very less than 1. Very less than. Now the taking second case, that is the sudden approximation. In the sudden approximation, the perturbation changes at a rapid rate within a some time interval such as t2 t plus tau. In this time, the perturbation मतलब h dash km is changes rapidly. During this time, the exponent in the integral changes by very small amount, so taken outside. In first case, diver h dash km upon diver t is taken outside. In second case, e to the power I omega km t is taken outside. This term produces perturbation. This is a constant term. तो इन एडियाबेटिक अप्रोक्सीमेशन जब आप पढ़ेंगे तो एच डैश के एम अपान एच डैश के एम, द रेट ऑफ चेंज ऑफ एच डैश के एम इज वेरी स्मॉल, सो इट विल बी टेकन आउटसाइड ऑफ द इंटीग्रल. और जब आप सडन अप्रोक्सीमेशन पढ़ेंगे तो दिस टर्म इज वेरी स्लो चेंजेस and this term is taken outside and this term is changes random. मतलब diver h dash km upon diver t, this is a rate of change of perturbed Hamiltonian and this is I omega km t is the exponential term. In case of adiabatic perturbation, this change is very small and approximately constant, so will be taken outside of the integral. And in sudden approximation, this will be taken outside of the integral, and this is a this is taken inside of the integral, and this will be taken outside of the integral. In this way, after solving will get AKT mod square, that is equal to diver h dash km upon diver t mod square h cut square omega km. The validity condition for sudden approximation is omega km very less than 1. In this case, transition will take place. Due to above reason, sudden approximation is superior than other type of the approximation.